This is chapter 3-3. This is recording number 2. Okay, so let me talk about this example 3-29 here, talking about the systolic blood pressure. So I'm trying to follow up here a little bit about these percentile graphs. Okay, now in case you don't know, I'm sure you've heard the word blood pressure before. There's systolic and there's diastolic. Systolic is the top number. That's when your heart is contracting. The diastolic is when the heart is not contracting. So that's kind of your resting blood pressure. So systolic, there's always going to be two numbers for blood pressure, but this is just the systolic. This is just the top one. Okay. All right. Now, as before, this A, B, C, D, you can kind of ignore that. That's just left over from the Excel spreadsheet labeling. So we got a frequency distribution. So remember, frequency distribution is what has already happened, as opposed to a probability distribution is what we think is going to happen, what we guess is going to happen. So this is a frequency distribution. They took readings of 200 people. Okay, here's our class boundaries. Here's our how many times, that's frequency. And then we're going to have a couple of columns here for the cumulative frequency and the cumulative percent. Okay, so here's the here's the boundaries, here's the frequency. We got to fill in these other columns here. All right, what are the steps? We find the cumulative frequencies, we place them in column C. Then what we do is we find the cumulative percentages and we put them in column D. Now remember what cumulative means. Cumulative means how many where are you at, and then how many were before you. So for this first boundary, the frequency is 24, so cumulative frequency would be 24. The next one here is cumulative, so that means this row right here, this class of 62 plus what came before. So 62 plus 24 would be what? 86. And then this one here would be 72 plus the 62 plus the 24. So as you can see, you just keep on adding them up. So it's 24, then it's 86. 86 plus 72 is 158. 158 plus 26 gives me this, and so forth. So that's my cumulative frequency. My cumulative percent is I just take the percent. That percentage is like here would be 24, a cumulative frequency would be 24 over 200. So let's see what that is. So it's 24 divided by 200. My calculator says is 0.12. Well, I don't want it to be 0.12. I don't like decimals. I prefer to use percentages. So I take the 0.12 and I multiply by 100. Okay, now let's take the next one. This one here, the cumulative frequency is 86. So my handy-dandy calculator says 86 divided by 200 is equal to 0.43. So again, I don't want it to be a 0.43. I want it to be a percentage. So 0.43 times 100 gives me 43%. So you just keep on going that way. And he tells you that right here. It's the cumulative frequency divided by the total number of people that were in the sample. That was the 200, and then you multiply by 100, so it's not a decimal, it's a percentage, okay? All right, so now we've got that. So now we graph the data. We're going to use the class boundaries for the x-axis, and then the percentages are going to be for the y-axis, okay? So let's take a look at that figure. It's all the way down here. Wait a minute. Okay, so here's the percentile graph for the example we just did, the example 3-29. That's the systolic blood pressure. It's a little bit awkward in this electronic version of the book. In this electronic version of the book, the figure is before the example, so it's a little bit hard to bounce back and forth. In your book, in your physical book, the graph, this cartoon here, this graph, is after the example. So it's a little bit easier to follow. And I'm sorry about that, but again, I have no control over that, obviously, okay? All right, so there's the cartoon, okay? Give me a second. I think what I'll do is I'll put the PDF version of the book up. It's the older edition, but it's probably close enough for government work. So give me just 1 second. Let me do that. Okay, so this is the 9th edition. I've sent this out to a few of you folks. I'll send it to anybody that wants it. If you got to learn how to use this is Adobe, I think, right? A PDF by Adobe. Yeah, Adobe Acrobat Reader. It's got the you can click back and forth here, and then you can go up here to these are the bookmarks, they call these, I believe. Okay, and it helps you go to specific parts of the book. So chapter 3 is where we're at now. Okay, and you keep clicking, come over here and click, go to where you want to go, which is, here it is, 3-3, measures of position, standard scores, boom, we're right here at percentiles. All right, so it's pretty easy to navigate around, I personally like physical books. All right, let me close this if I can. There we go. Let me close this if I can. Now I can kind of get a little bit more of a close-up here. Okay, so help me out here. Give me a second. Let me find it. Okay, so in the PDF version, it's the graph comes after the example itself. Okay, so we already did all this. We talked about this, finding the cumulative frequency, cumulative percent. Okay, and then it says graph the data, and we use the class boundaries for the x-axis and the percentages for the y-axis, right? Okay, so how do we do that? Right here. Here's the class boundaries. Okay, goes from 89.5 to 104.5 to 119.5, right? There it is. Okay, so those are that's the x-axis, and then we have the cumulative frequency. Now, at the very beginning, the cumulative, or the percentages, I guess I should say, the cumulative percentages. At the very, very beginning, it's 0, right? You start at 0. Then when you get to 104.5, that data point right there is plotted here. Then the next upper bound for the class boundary is 119.5. That's that data point. So hopefully you got your book and you're looking with me here. See, so it would be 104.5 should be 12, 119.5 should be 43. That's the cumulative percentage. So is that what we have here? 104.5 is about 12%, looks about right. 119.5 is about, what did I just say? Okay, so I looked at my book because it's just too hard to go up and down on this thing. So 119.5, the cumulative percentage is 43. So right there, that data point right there is about 43%, and so forth. Okay, 134.5 comes up here. 134.5 is 79%, and there it is. Okay, do you see how that when you plot this data, if you do it on paper, it's a lot easier because you have graph paper. You have the little boxes. Okay, so now how do we use this graph? Once we have this graph, now we can use it. So for example, to find the percentile rank of a blood pressure reading of 130, okay, we find 130 on the axis, draw a vertical line up to the graph, then you move horizontally. So here we go, 130. So 130 is about right here. Okay, we go up to here and go to the left to here. So 130 is about 70 percentile. The cumulative percentile is about 70. There it is, right there. Find 130, draw a vertical line, move horizontally, and it's about the 70th percentile. Can you see that? I hope you can. I go from here, 130, up to here, and then over this way. Okay, now suppose on the other hand you say, well, I want to know what would be the value that corresponds to the 40th percentile. So what do? You start here at the 40th percentile, you go this away until you hit this graph line here, and then you come down, and you kind of estimate where you are. Okay, so he estimated that you were at 118. So for the 40th percentile, you come over here, you come down, you're at about 118. Okay, so in real life, if you have a job where you're analyzing data, typically, you would do something like this. You'd use something like this to try to explain to the bosses, to the customers, or whoever, kind of, whatever information you're trying to convey, these graphs convey the information a lot better than just having something like this. Okay, this does not do well to try to explain things to people. Okay. All right, and then of course this is only approximate results, it's approximate answers because they're graphs. Okay, so we got to find a better way of doing this if we want exact answers. So let me close this PDF here, and I'm going to go back. I'm going to go back to the electronic version. Here we go. We're back to the electronic version. That was just awkward because of where they put the graph. All right, so here's a little more precise version of how to find these answers. So this first one here is the word given here. In other words, if you give me a value of x, if you tell me the value of x that you're interested in, and you want to know what the percentile is that corresponds to that value of x, here's the formula that we use. We line up the data points, and we take the number of data points that's below x, we add 0.5, just to kind of account for continuity, I guess you'd have to say. Let's just take the formula at face value. So you add 0.5, because this is the number of values. That's going to be a counting number. There's going to be 5, there's going to be 6, there's going to be 7, whatever it is. So plus 0.5, and then you divide by the total number of values. That'll give you a decimal answer. You multiply by 100 to convert it to percentages. So let's take a look here. The number of traffic violations recorded by the police department is shown below. I want a percentile rank of 16. Okay, so the first day I got 22 violations, the next day I got 19, the next day I got 25, and so forth. Where is 16 in this grand scheme of things? Well, we arrange the data in order from the lowest to the highest. We plug it into the formula. Okay, I want to know what it is for 16. So I go a little bit above 16. That's the number of values below x plus 0.15. So it's 1, 2, 3. There's 3 below 16, right? Here's 16. There's 3 numbers below that, or there's 3 data points below 16. So I take the 3 plus 0.5. How many total number of values are there? There's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divide it by 10. That gives me a decimal, and that gives me a decimal of 3.5, or I'm sorry, 0.35. Multiply that by 100, and that gives me the 35th percentile. That's a 35%. Okay, so the value of 16 is higher than 35% of the data values. So 16 is above 35% of them. Okay, all right. So again, this example isn't very interesting, but it's just an example. All right. Okay, so now here's another example of how to do it. I'll leave that to you. Now let's take the other thing you might be interested in is going to be if you give me the percentile. See, the word given here is the most important word. You're giving me the percentile, and I want to find the value that corresponds to that. Before, you gave me the value of x, and I wanted to find the percentile that corresponded to that. So it's a totally different, it's just vice versa, right? Okay, so how do we do it? Here's the procedure table. I'm going to have to do that on the next video because I'm out of time.